Welcome class. Thank you for joining me for our practice test for 6A. So in this video, I'm going to step through the entire practice test for you so you have a study material for tonight. Now do make sure, just like with the notes, you should be following along and doing everything that I'm doing. Writing down the notes, and you should have a calculator in front of you so you can be doing the calculations too. Because remember, a lot of this when it comes to the cubed roots, fourth roots, stuff like that, you need to make sure you know how to use the calculator to do those values for you. Now beginning with this, so this first section is from our little concept bite, our review from exponential algebra for rules of exponents. So the first thing that I notice is I have the exponent of 2 there, all right? Now the exponent of 2, when you have a parenthesis to a power or a product of powers, you end up taking that power to everything inside the parenthesis. So you get 5 squared, which is 25, x to the third squared. Now remember, power of a power, you multiply, and then y to the negative 4 squared. So again, you multiply your powers. That is one of the key things. Power of a power, you multiply. All right, well, now that we've taken care of that power of a power, now we're ready to do our multiplication rules. Now remember, when we're multiplying, so here we have an x to the 6 times an x to the 4. Remember, for the multiplying step, we're now adding exponents. All right, so again, it's one of those confusing things. It seems really backwards, but something you need to remember from Expo. Y to the negative 8 times y to the 7. Well, negative 8 plus 7 will leave you with a negative 1. Now, another thing to note, we don't like negative exponents. So remember, because we have that y to the negative 1, remember our final answer, when we move that to the denominator to give it a positive exponent. So we'll move that to be a y to the first power down in the denominator. And now finally, that can be our final answer. All right, now for number 2. So this one is just kind of a hot mess of a fraction. So I'm going to take it step by step, piece by piece. So the first thing I'm going to do, 36 divided by 12, that actually turns out nicely. That's just going to give me the number 3. All right, now notice we have a to the 5 divided by a to the negative 1. Now remember, for division, we're talking about subtracting the exponents. So here, 5 minus negative 1. Well, 5 minus a negative 1 is the same thing as 5 plus 1. So we're actually going to end up with an a to the 6. For that b, so now we have b to the negative 7 divided by b to the 2. Well, negative 7 minus 2. That's going to make it even more negative, and we're going to end up with a negative 9 there. And then c to the first divided by c to the 3. 1 minus 3 leaves me with a negative 2. All right, now remember, what those negative exponents really mean is that those pieces are going to end up in the denominator. So we have a b to the 9 that we move downstairs, and that c squared we move downstairs, so they can have positive exponents. And now finally, that can be our final answer. So moving right along. Now this one, that power rule. So here we have an entire parenthesis taken to an exponent. Well, the same thing holds true here. That negative 3 exponent is going to influence everything in the parenthesis. So we're going to end up with a 5 to the negative 3 power, m squared to the negative 3. We multiply those exponents, power of a power, a 2 to the negative 3. And now, n to the negative 3 to the negative 3rd power, when we multiply those, we get a positive 9. So now we have a lot of flip-flopping to do, okay? Because that 2 to the negative 3, that's going to end up upstairs. We have to flip-flop its location because of that negative exponent. The 5 moves downstairs, the m moves downstairs, and the n stays downstairs. So again, after you apply any exponent rules, if you have any negatives, you just move it around. Now, for the final step, just to make this look a little bit cleaner, whenever you have a number to an exponent, actually calculate out that number. So instead of 2 to the third, I'm going to call that 8. Instead of 5 to the third, I'm going to call that 125. Again, just to make it look a little bit nicer for us. And then that is going to be our final answer once again. So again, that's just a little review because this stuff is going to come back in the next section for us. So it's really important that we understand these rules of exponents to make the next section easier on us. Now, moving on to the real meat of Chapter 6. So Chapter 6 is talking all about roots. Now, remember, when it is in words, that means even powers need the plus and minus. So if you need to write that on there to remind yourself, because I saw a lot of people messing that up on that first practice sheet that you turned in. So remember, when it's in words, the even roots need plus or minuses. Square root, that is an even root. So when I square root 169, I get plus or minus 13. Now when I try to square root negative 49, now hopefully you remember this, but the calculator will remind you if you don't. When you try to square root a negative, there are no real solutions. That is not a real number when you try to square root a negative. And remember, one of the things we like about Chapter 6, one of the redeeming features of Chapter 6, is we're only dealing with real numbers. Now, number 5, now we're dealing with cube roots. So now the whole plus or minus thing doesn't matter because that's only even roots that it applies to. So when you type these into the calculator, you end up getting a negative 6. And then for this one, remember when you use the calculator for fractions, make sure you use parentheses so nothing weird happens. All right? And also, when you calculate this one out, remember to turn it back into a fraction, you can go into math and then that arrow fraction button because that'll let you get this to 7/5. So don't forget those calculator commands, please, of using parentheses, that math to fraction, stuff like that, so you can get the most exact answer as possible. So after we learned how to basically use a calculator to take roots, then we moved on into actually doing these. Now, one of the biggest things here, absolute values when needed. That means even roots. So the first thing I'm going to do for every one of these, this is an even root. So that's going to remind me that I need to take the absolute value of what I'm pulling out. So the square root of 225, if you look at your powers chart, that is 15. X to the 4, well remember, there's a secret 2 there. Now 2 nicely goes into 4. 2 goes into 4 twice. And then 2 goes into 10 5 times evenly. But remember, we need those absolute values. Well, a number, so that number 15 never needs to be inside the absolute value because it's already positive. X squared, anything to an even exponent doesn't need the absolute value because it's automatically going to be positive. The only thing that needs to stay inside is that y to the 5 because that potentially could be negative. And so that is going to be our final answer, where you need to get to for me. All right, now this next one is odd. So that means that absolute value doesn't apply to this problem. Remember, we're only going to apply it to even roots. So cubed root of negative 27. Well, your chart tells you the cubed root of positive 27 is 3. So the cubed root of negative 27 is going to be negative 3. Now, 3 goes into 6 twice. So it's going to pull out as an x squared. And in this instance, that's a final answer. That's all that we need to get to. All right, so again, moving right along. So the fourth root of 6, oh, sorry, before I start, remember to help remind myself, it's even. So this time, I do need my absolute value signs. Now, the fourth root of 16, if you look at your powers chart, is actually, again, a nice number. It is the number 2. Now, 4 does not go into 6 nicely. So now we have to start considering. So the number 4, it goes into 6 once. So I can pull out an x to the first. But then there's a remainder of 2 left inside the square root. In terms of the y's, 4 goes into 7 once. But then there's a remainder of 3 that's left inside the radical. And because we're talking about an even root, remember absolute value, that number never needs to stay inside. So that 2 can come out automatically. But that x and y both have odd powers. So both of those could potentially be negative. So I'm going to keep those inside my absolute value and then write those. And that's the form that you should leave your final answer in. All right, number 9. All right, well, this time it's an odd root, so we don't have to worry about taking absolute values. Now, looking at 54, though. So this time 54, it is not appearing on your powers chart. So remember, this is the secondary use of the powers chart. If it's not a number that's actually on it, you're looking to see what number on your chart divides the number we're talking about. So you should be looking for what number divides 54 on the cubed list. Well, you should see 27 divides 54. In fact, it is 27 times 2. So when we go to break this apart, well, the cubed root of 27, you should know, is 3. And then we have that cubed root of 2 left inside. All right, now, the a. So 3 can't go into 2. A number can't go into a number less than it. So none of the a is actually able to come out. The entire a is still stuck inside, that a squared. However, that 3 goes nicely into the 9. 3 goes into 9 3 times, so that gets pulled out as a b cubed. And that is actually how we can leave our final answer. So I'm going to make sure I have that written down before I keep moving along. Number 10, so this is another case. Now, we're dealing with an even root, so that means I do need to consider my absolute value. 98 is not on my powers chart. You should be looking at the second power list. Well, 98 isn't on it. However, 49 goes into 98. In fact, 49 goes into 98 twice. So the square root of 49 is 7. And then that 2 is left inside the square root. Well, now remember, a square root is basically having a 2 out there. So 2 goes into 6 3 times. So you can pull out an s to the 3. 2 goes into 12 6 times. So you can pull that out as a t to the 6. Keeping in mind, because it's even, we have to put our absolute value signs on it. So remember, a number will never need to stay inside the absolute value. And anything to an even power will never have to stay inside because we know it's automatically positive. So the only thing we're worried about is that s to the third. That could potentially be negative. And then our square root of 2. All right, number 11. Well, this is an odd root, so we don't really have to worry about our absolute values. And 250 is not a perfect cube. It's not actually on the chart. However, if you notice, 125 is on your chart. 125 times 2. So the cube root of 125 is the number 5. And then that 2 is left inside the cubed root. Well, now for that y to the 7. Well, 3 goes into 7, not evenly, but 3 can go into 7 twice, but there's going to be 1 left over then. And so we represent our answer by pulling out a y squared for the 2 times 3 goes into 7. Then the remainder of 1, so y to the first, is stuck inside. All right, our next example. So this time we're looking at a much further column. This time we're looking at the 5th power column. So 5th power column. So looking at that, you should be looking for numbers that divide 32, that divide 96, and you're going to come across 32. Now, I'm going to pull the negative with that 32. So 96 is 32 times 3. And again, I'm pulling the negative out of the root too. So the 5th root of negative 32 is going to give me a negative 2. And forgive me, I just realized I forgot to indicate. This is odd, so we don't have to worry about absolute value. All right, I apologize. So back on track. And then we have the 5th root of 3 stuck inside the radical. So now let's start looking at our exponents. So the x to the 7, well, 5 goes into 7 one time completely. So I can pull out an x to the first. And then there's that remainder of 2. There's going to be 2 left over. Now the y to the 8. Well, 5 goes into 8 one time completely. So I can pull out a y to the first. And this time, there's going to be a remainder of 3. There are 3 left over. And that represents our final answer. All right, shifting gears. So on the back side, we need to simplify each expression, rationalize any denominators when needed. And now notice this, assume that all variables are positive. So this is very much to our benefit, getting to make that assumption, because what that assumption means, no absolute values. All right. So when it gives you the instruction that you can assume all variables are positive, that means you no longer need absolute values. So all of this back page actually just got a little bit nicer. The little redeeming feature of the back page, you don't need to do those absolute values anymore. Now, looking at 13 and 14. Now, remember, when you're looking at fractions, the biggest thing that I can tell you, reduce the fraction first. Your life will be so much easier if you remember to reduce fractions first. What I mean by that is a number 13, 180 divided by 5, that gives you 36. X to the first divided by x to the 7. Well, 1 take away 7 leaves you negative 6. Well, I'm just going to jump and put that directly on the bottom as 6. Okay, there were 6 more x's on the bottom than there were on top. Y to the 5 divided by y to the 3. 5 minus 3 leaves me with 2. So notice just how much nicer this is already, because I know the square root of 36. That is the number 6. The square root of y squared, well, 2 goes into 2 once, so I get a y. Then on the bottom, 2 goes into 6 3 times, so I get an x cubed on the bottom. And again, because I get to make that assumption that variables are positive, I can just leave it at that. I don't need to worry about my absolute values anymore. The next one. So here, excuse me. So let's take a look at what we're getting. Well, 7 over 6. 7 over 6, that fraction can't reduce. So there's nothing we can do with those numbers. However, a to the first divided by a squared, 1 minus 2 is a negative 1. What that negative 1 means is that I'm going to have an a to the first on the bottom. B squared divided by b to the first. 2 minus 1 leaves me just 1, so I have a b upstairs. C cubed divided by c squared. 3 minus 2 is 1, so I have a c to the first on top. Now, unfortunately, this is not the end. Unfortunately, we have a radical in the denominator, and we have to get rid of it. Now, remember, to get rid of radicals on the bottom, we need to complete the radical. All right, so I have a 6 on the bottom. Well, this is a cube root. So to complete the cube, I need 2 more 6s. 6 times 6 leaves me with 36. I have an a on the bottom. And again, to complete a cube, I need 2 more a's. So I need a squared down there. And remember, once we identify that, really, we need to multiply the top and bottom by that same thing to ensure we're not changing the value of this fraction. So on top, 7 times 36 is 252. And then I just put my variables together. A squared BC. On the bottom, 6 times 36. That gives me 216. A times a squared gives me an a cubed. Now there's something very special about that. The whole point of this rationalizing the denominator process is because now that right there, the cubed root of 216 is just the number 6. The cubed root of a cubed is a. So the whole point of that is by doing it, we've removed the radical from the denominator. It's no longer down there. All right, so moving on to these binomial expressions. So remember, the key to these binomial expressions is foiling. So let's FOIL this out. 7 times 7 gives me 49. 7 times 2 square roots of 3. Well, I can combine the outsides, so that 2 times 7 gives me 14. Negative 2 square roots of 3 times 7 gives me a negative 14 square root of 3. And now finally, negative 2 square roots of 3, 2 square roots of 3. So remember, you can combine the outsides. 2 times 2 is 4. And combine the insides. 3 times 3 is 9. All right, now, however, square root of 9. We know that that's a nice number. The square root of 9 is just the number 3. So 4 times 3, I'm going to call that 12. So now when I go to simplify this, notice these insides cancel. 14 square roots of 3 minus 14 square roots of 3 cancel off. 49 minus 12 leaves you with 37. Now, I said foiling is the key here, But number 16, it doesn't look like I can FOIL it yet. Now, number 16, this is where you need to remember that you should write this out twice. When you have it squared like that, remember that's the same thing as it multiplying itself. So when I look at that now, this is something that I can FOIL. Square root of 11 times square root of 11, square root of 121, 5 square roots of 11, another 5 square roots of 11, and then finally 25. Now, square root of 121. Again, hopefully you recognize that as a nice number. The square root of 121 is just the number 11. So 11 plus 25 gives me 36. And both of those combine too, so you get 10 square roots of 11. And that is how you can leave your answer. All right, so 17. So 17 is that problem where we need to use the conjugate. All right, we have to flip the sign in the middle so we can end up removing that denominator. So I'm going to multiply this by flipping that sign. So I'm going to say square root of 5 minus 3. But again, when you're rationalizing the denominator, you have to multiply top and bottom by the same thing. All right, so on the top is just a simple distribution. So we get 2 square roots of 5 minus 6. So the top isn't a big deal at all. The bottom, however, the bottom ends up being a FOILing problem. So we get the square root of 25 minus 3 square roots of 5 plus 3 square roots of 5 minus 9. All right, so again, all I did is I FOILed out that bottom. Now, square root of 25. We more commonly know that as 5. Also, these two inner pieces cancel. When you're multiplying by the conjugate, that should always happen. If it doesn't, it means that something is wrong. So, on the top, we have 2 square roots of 5 minus 6. On the bottom, 5 minus 9 leaves you with negative 4. All right, now, this is where a little bit more simplification can actually happen. Because notice, 2 divided by negative 4 leaves you with, oh, I apologize. Please ignore that. That leaves you with just a negative square root of 5 over 2. And then both of those can reduce by 2 as well. So you end up with a plus 3. So what did I end up doing there? Well, essentially, I just took 2 out of everything. All right, so I divided everything on the top and bottom by 2. Now, if you want to write this in a better form, you could call this that. However, either one of these forms I'm okay with. Those are the same thing. So if you can get to that point, either version will get you full credit for your answer. So 18. For 18, for multiplying, all you have to do is multiply the insides. 3 times 12 is 36. X to the first times x to the 7. Add your exponents. That leaves you with an x to the 8. Well, now we know the square root of 36. The square root of 36 is just the number 6. 2 goes into 8 4 times, so we can pull out an x to the 4. And again, we get to assume everything's positive on this backside, so that is the end of our problem. All right, so we're nearing the end. Only 3 more problems to go. So one's like 19. So for number 19, remember we can only add like radicals. So what that means is right now we can't add these. However, we can simplify them first and then potentially get to add them. So square root of 20, if you look at your powers chart for what divides 20, you'll see the square root of 4. So I'm going to break it up into the square root of 4 and square root of 5. Looking at 18, well, which perfect square goes into 18? Well, 16 times 5. And then we're not going to simplify the square root of 5 at all. That we can't do anything with. All right, now, so I pulled out the perfect squares. So now that square root of 4 turns into a 2. The square root of 16 turns into a 4. Well, 4 times 3, so that's going to be a 12 out front now. And then again, that last thing is 7 square root of 5 for now, just stay the same. Well, now these all have the same root, okay? They're all the square root of 5. So I'm going to add these up. 2 plus 14 is, or 2 plus 12 is 14, minus 7 leaves me 7 of those square roots of 5. Number 20. So number 20 is another case of having to rationalize the denominator. All right, so I want you to notice we're dealing with a 4th root this time, so we need 4 of the same thing to complete that root. So I already have 1 2, so I need 3 more 2's to complete that root. 2 times 2 times 2 leaves me with 8. And I multiply that by the top and the bottom. So on top, I'm left with the 4th root of 56. On the bottom, I have the 4th root of 16. However, remember, the point of this is that root should disappear. So the 4th root of 16, you more commonly know that as the number 2. So you should simplify that to 2, and now that is the end of our problem. All right, and our last example. So for our last one, remember the key to this type of multiplication problem is multiply the outsides. So I get 15. And then you're going to multiply the insides. So 4 times 32 is 128. Y to the 2 times y to the 5, add the exponents, you get a y to the 7. All right, so here we're looking for what perfect cube divides 128. So you should notice on your power chart, 128 is divisible by 64. It is 64 times 2. So the 164, the cube root of 164 turns out to be 4. Then that 2 has to stay inside the cube root. Now we have to deal with that y to the 7. So remember with those exponents, we look to see 3 goes into 7 twice. So we can completely pull out a y squared, but there's a remainder of 1. There's 1 left over that didn't fit. So that one has to stay inside. And now, just to clean this up a little bit, 15 times 4 is 60. So we get 60y squared, and we still have a 2y stuck inside the radical. So thank you so much for joining me and watching through these notes. Now, this will also be up on YouTube and in Modo. So when you're studying tonight, if you've forgotten a step that I took, if you want to review some more, this is going to be posted and available to you to watch multiple times as you're studying. So please make use of this resource. And good luck in your studies tonight. And I look forward to seeing you tomorrow for your test.